All right, so we changed your homework up a little bit tonight. We're going to be talking about pages 12 through 13, which was your classwork from today, so you can make sure it is completed and corrected. And then also there's a little bit of checkup review here at the end. So those should give you some tips and tricks to think about on your quiz tomorrow. Our classwork problem today focused on grocery stores and thinking about which store has the better price for groceries. And so we're starting off by finding two unit rates, and the suggestion was to set up and solve proportions to figure those out. So for example, if it is $6 to get 7 boxes, then I want to know how many dollars would it be for 1 box. My other unit rate is going to be flipping this around. So again, if it's 7 boxes for $6, how many boxes would I get for $1? So I'm going to set up some scale factors here. 7 times 1/7 would give me 1. 6 times 1/7 would give me 6 divided by 7, which is approximately 86 or 87 cents per box. My other unit rate is 6 times 1/6 to get me to 1. 7 times 1/6 gets me to approximately 1.16 boxes. So in other words, I get about 1 1600ths of a box for spending just $1. Now it's not very likely that a grocery store would be willing to take a box of pasta and cut it into the right number of pieces, but that's what that unit rate is referring to. So if we fill in our table here, $1 would purchase 1.16 boxes. 1 box would cost 86 cents. Again, you might have rounded up to 1.17 or 87, just kind of depends on what you did. So now the other store, we're going to do the same thing. So $5 for 6 boxes means how many dollars for 1 box? And flipping this around, 6 boxes for $5 means how many boxes per $1? So scale factor, 6 times 1/6 would give me 1. 5 times 1/6 gives me about 83 cents. So 83 cents per box. And over here, my scale factor is 1/5. And 6 divided by 1/5, I get 1 2/10. So I get 1 2/10 of a box for $1. Now I'm going to go ahead and write my equations. So for More for Your Money grocery store, I know this is the one that we did first. It's on this other side here. We had one rate that was 86 cents per box. And my other rate was 1.16 boxes per dollar. And the fresh food store, it was 83 cents per box and 1 2/10 of a box per dollar. So now I'm going to put these into equations. And remember, what you see here with the rate actually gives you a clue of how to set up the equation. So 83 cents per box. So notice this starts with dollars. So my equation is going to start with dollars also. In this case, I'm going to call the dollar C for cost. So cost equals 83 cents, and then per box, I'm going to put an N here. I'm going to use the variable N for number of boxes. At More for Your Money grocery store, it was 86 cents per box. So again, it was 86 cents. So my equation starts with cost equals 86 cents per box. I'm going to put my N here. And now on the second equation, I'm going to write it a different way because now I'm talking about boxes per dollar. So my equation is going to start with N for number of boxes equals 1 2/10 times C, dollars. The next one, I have 1 1600ths boxes, so N equals this rate per dollar. This is going to be C. So check your equations and make sure you're setting them up correctly. Remember, the rate is going to determine how you set up the equation. Okay, now we're going to go ahead and graph our relationships. So again, pay attention to which store goes where. This first one is going to be C equals 86 cents times N, the number of boxes, and fresh foods is going to be C equals 83 cents times N, number of boxes. So again, when you're setting this up, if you look at your unit rate, that's going to help you figure out what you're dealing with. So it's 86 cents per box, N. And so N is going to go on the bottom here. I'm going to use a scale of ones. So 1, 2, 3, 4, 5. If it helps, you can even put in the value for 0 so you know where the origin is. And then that means cost is going to go on the other side. And to make my graph really simple, I'm just going to go by my rate. So it's 86 cents. So then I'm going to continue up in intervals of 86 cents. So if I add 86 cents to 86 cents, I get $1.72. Plus 86 cents, I get $2.58. Plus 86 cents, I get $3.44. And plus 86 cents, I get $4.30. I'm just going to keep my graph really simple here. So I'm going to plot some points. So one box would cost 86 cents, 2 boxes, $1.72, 3 boxes, $2.58. And I can see that I've got a line going just like this all the way through. Remember that I do have a point at 0, 0 because this is a proportional relationship. And again, I know it's a proportional relationship also because I see this lovely constant of proportionality right here, also known as a unit rate. All right, now fresh food store, very similar. Again, we're talking about 83 cents per box. So boxes is going to go on the bottom N. Again, I'm just going to go by one since it's per box to make it simple. Again, you can mark in 0 if it helps. I know there's going to be a point at 0, 0. And now this scale is going to be 83 cents. And over here again is cost. So I have 83 cents and I'm going to add 83 cents again, which gives me $1.66. I'm going to add 83 cents again, which gives me $2.49. Again gives me $3.32. Again gives me $4.15. And now I can plot those points. So again, one box is 83 cents, 2 boxes is $1.66, 3 boxes is $2.49. And again, I can connect that into a line. Now be careful again to think about how the lines may look just the same, but in reality, these are slightly different relationships, right? One is 83 cents per box, one is 86 cents per box. So be careful to notice that the scales here are different on the side where it goes by cost, even though the lines themselves look very similar. Now we're going to graph the other set of equations. So more for your money was N equals 1.16 or 1 1600ths of a box per dollar. So that's going to have a C there. And the other was N equals 1 2/10 times the C there. So this time it's $1.16 boxes per dollar. And so cost is going to go on the x-axis. And so here we're going to set this up per dollar. We're going to go by ones just to make it simple. It's the same thing on the other side because it's per dollar. So 1, 2, 3, 4, 5. And again, this is cost. That means that N is going to go on what we call the y-axis. Later on, we'll start to call this the dependent variable or the dependent axis. That's coming. And then I'm going to use my unit rate to help me figure out my scale. So here I'm going to use 1.16 or 1 1600ths. And so I've got 1.16 plus 1.16 again gets me to $2 or two. This is not in money actually. This is the way where it's often kind of tricky to say some of these rates because you accidentally say dollars sometimes when you don't mean to. So again, this means I get 2.32 boxes for $2. Then I get 3.48 boxes for $3. Then I get 4.64 boxes for $4. And finally, 5.8 boxes for $5. And remember, again, there's a point at 0, 0 since this is proportional. Hopefully your line's a little straighter than mine. And that will work for the first one. Over here, we're going to go by 1 2/10. So 1 2/10, 2 4/10, 3 6/10, 4 8/10, and 6. And so again, point at 0, 0. one box, $1 will purchase 1 2/10 of a box, $2 will purchase 2 4/10 of a box, etc. And so we can go ahead again and graph that line. And we are done at this point with graphing. So now let's think about at which store Gus should buy pasta. And so this is a good question to think about with unit rates. So again, when it came to more for your money, I'm going to say MM grocery store, more for your money grocery store. And then we also had Fresh Foods grocery store. More for your money was 86 cents per box. Fresh Foods was 83 cents per box. So based on that information, I'm tempted to want to pay probably less per box. So that means that Fresh Foods is probably a better value. If you're looking at the other unit rate, right, we had 1 1600ths of a box per dollar, and we had 1 2/10 of a box per dollar. And so if you were looking at those and thinking, how does that help me figure it out? Well, in this case, with that situation, I want to get more of a box for my money. So again, this unit rate would help me determine I still want that box, or I still want that particular grocery store, so I get more pasta for my money. But that also will cost less money per box. So Fresh Foods is probably our best choice. Now let's start talking about some quiz review for tomorrow. So one of the problems you're going to see on your quiz tomorrow is going to talk about tables. And if you think back to that pizza problem we had at the beginning, we had a large table and a small table. And so if we have a large table here, for example, that has 14 people who can sit there, and we have 9 pizzas, we want to think about how much pizza does each person get. So if I want to know how much pizza per person, I'm going to be setting up this type of fraction where I put pizzas on top and I divide it by the number of people. So that means a fraction of 9 over 14, because again, I'm dividing pizzas by people. It doesn't really work to divide people by pizzas. As a decimal, I can go ahead and divide 9 divided by 14, and that would give me this decimal here, which would be about 64 hundredths. And then when I turn that into a percent, that's 64%. So that means that each person would get 64% of a pizza. That's not saying 64% of every single pizza, but of a or one pizza. Now we have the small table. Small table has 12 people and 7 pizzas. So we're going to again set up pizza divided by people. So my fraction is 7 pizzas divided by 12 people. It's already simplified, so I'm just going to leave it like that. To find the decimal, I'm going to do 7 divided by 12, and then I get around 58 hundredths. And as a percent, this would be 58%. So if I was asked which table I'd prefer to sit at, well, I would probably say I want to sit at the large table if I like pizza, because then I'm actually going to get more pizza. That table gets more pizza per person. If I don't like pizza, then maybe I'd rather sit at the small table because I wouldn't get quite as much. So for tomorrow, please be thinking about all these big concepts we've talked about: unit rates, constant of proportionality, how to make graphs, how to make unit rate tables, how to make equations. These are all really big, important concepts, and we look forward to seeing how you do tomorrow because we know you can do it.